There's a few things that are different about this table. We're going to still do the exact same thing. It's asking to find the modal class, which is asking for the mode. But since we've got a range or classes now with our notes, it's going to be a little bit different. So this is asking us to find the same amount of information. It's just presented to us differently. A, because there's now a range of data. And also because now we've got frequency as a thing that's going on. So let's talk about how to enter that into our calculator. I'm going to scroll up, highlight everything and press delete, delete, delete. I'm going to go first and enter in this information right here. Now, we cannot enter a range of data. So in order to represent that range of data, we have to use the class midpoint. Mentioned that in the notes like a couple notes ago, and I was like, this is something that's like pretty straightforward. We're going to use it later. And so this is where we're using it. We're using it to be able to represent all of the data that's within this range. It's kind of like your interpolation, your nearest neighbor interpolation. So coming from your Voronoi diagrams, remember how we had like a site, a bubble that was like had a polygon size or a polygon shape. We had a site, we had a cell, and then the site in the middle of that cell represented all of the data in that cell. And so then we said, okay, well, if you are in that cell, then you use this small little dot that's in the center of the cell to represent all of the data. And so it's kind of the same thing that we're going to use the class midpoint that's in the middle of the range to represent all of the points of data that are within that range. Now, obviously, they aren't all going to be 2.5. Both of these guys might not be 2.5. They might both be 2. But since we don't know what they are exactly, we just know what they are in a range, we're going to say 2.5 is an accurate representation of where that information lies. So what we put in our list in our calculator is the class midpoint. So my first one is going to be 2.5. And my next one is going to be 3.5, 4.5, all the way to 8.5. Okay, after that, we now have to list the frequency in the next list over, just how we see it in the table anyway. And then we go and do the exact same thing that we did before when we're calculating this. We're going to go to statistics, stat calculations, one variable statistics. Okay, we want our X1 list to be A. Now we have frequency. So we need to say, hey, the frequency list is in B. And remember that you have to have those little bracket guys. And then we're going to put the results in column C. And there we go. So modal class, again, mode is not given to us in the calculator, but we can go find it. We want to see what has the highest frequency, and the highest frequency is here, 9. It's in the class between 7 and 8. So the modal class is between 7 and 8, which means that most of our data lies between that range. Now it will always say approximation when you have a range like this. So this is your approximation because we approximated each of these points of data to be about the midpoint of that. So the approximation of the mean is your mean that's right over here. It's just you have to recognize that it's an about. And the approximation is 5.86. And then your approximation for the median, again, if you go down to your median, you just grab your median. It's just that the median we have to recognize is an approximate because we used a guess for what's going on. Okay. So it says comment on the meaning of these values and state which is the most appropriate to use in each case, giving a reason for your answer. So I want you to notice here that both the mean and the median, mean and median, fall in the same range, which is between 5 and 6. However, since the modal class is significantly higher, so not just by one class, right? If this is where our median and our mean are, but then our modal class is up here, going two more classes up to be where your mode is pretty significant in relation to the rest of this data. When we only have so many classes, moving two classes to get to the mode is a pretty significant jump. And we'll talk about these graphs that are down here on the bottom, and you can see that when the mode is two jumps away, your data is skewed. Since the modal class is significantly higher, the mean would be the more accurate representation. This is because both the median and the mode rely on the number of data points. And so since we can recognize that the mode is highly skewed, that then the median would be affected by the result that the mode is highly skewed, right? If we think about chopping off the edges to get to the median in the middle, that mode is going to take off a lot of those chops that were then starting to like really come in closer to here. So it's really affecting where the median goes because we're really heavily focused on this mode right here. Whereas the mean tends to, yes, it's still heavily focused or heavily dragged down or up by the mode, but it still includes all of the points of data that are necessary in its final calculation. Whereas median truncates off points of data, and so it can be really skewed if the mode is skewed. So let's talk about what this guy is above. When our mean and our median are pretty close within the same range, but then our mode is a couple jumps away, you'll see that then the histogram tends to look something like this. And this is when we call it skewed data, right? And I'm sure you've heard the word of like skewed data, and it might not have a very good connotation. Remember that in data and with statistics, you want to try and take away as much emotion in this as possible. So it's skewed. Whatever that means, it just means that the data is skewed when your mode is significantly different from your mean and your median. This is a highly central tendency data where your mean and your median and your mode all fall within the same range. And that's the goal. So you'll see like a lot of test scores. We hope that all the test scores have this central tendency that's like that. When I've shown you the breakdown of your grades before in the little spreadsheets, and I've shown you that bar graph, which is a histogram, the hope is that we have this bell curve to it. All right, this whole page right here is central tendency. There we go. This is how we measure it. This is what we care about. This is central tendency, what's going on. Mean, median, mode, different ways to think about it. Now we're going to talk about the measures of variability and spread. So we're talking about how far out does everything go. So Mr. Kuwelty and Ms. Zaffron give the same test. They're 11th graders. After grading all of the tests, the scores are as follows. So those are supposed to be comments. So we've got all of these guys, and I want you to really quickly find the mean on all of them. So I'll say mean for Kuwelty and mean for Zaffron. Okay, so for Kuwelty, we should have gotten 70, and for Zaffron, we should have also gotten 70. So when we get the same mean, the same representation of central tendency, it can really disrupt what our impression of the data can be. So we have the same mean value, but widely different data. Kuwelty's mean of 70 is a more accurate representation of the data, because realize that 70 is about right if you have data that's between 60 and 80. That seems to be like, okay, yeah, like if you said that the average was 70, being somewhere between 60 and 80 is a good representation. of that data. Whereas Ms. Zaffron's measure of mean is 70. If you got a 50 on the test and you saw that the average was 70, you would probably be like, not happy with that, right? Or if you got a 95 out of 70, you might be like really surprised by that 95 as your score when the mean is 70, right? So that idea of being surprised, hearing the mean and then seeing your data means that that mean is not a good representation of the data, not a good way to look at the data. So Coelti's mean is a good representation. And Zaffron's mean is a bad representation. So sometimes relying on just the central tendency to summarize data can be very misleading. So you have to think about how spread out is the data. So you can see here, this right here is Coelti's data, and this right here is Zaffron's data. Still, the mean is the same, but here you can see that the spread is very, very small, whereas Zaffron's spread is a very large spread. So small spread, which we call a range, versus a large spread or range. It means that Ms. Zaffron's scores have a high variability. So you can write that down, high variability, whereas Coelti's has a low variability. For better or for worse, right? It could be scores, but it could also be people in the world, and you want the people in the world to have a high variability, right? You want people to be different because it makes the world more interesting. So for whatever it means in the context of the situation, it's just what the reality of the data is that some have small variability, some have large variability, for better or for worse.